Hi, and welcome to the workshop on the changes in the CAPE mathematics curriculum. Today we'll be paying special attention to the school-based assessment, that is, the pure mathematics component. Let us first start with a quote from a Nobel Memorial Prize winner in economics. I have always been interested in using mathematics to make the world better. This is an interesting quote because it mirrors the very tenet of our revised pure mathematics syllabus. The main goal is to demonstrate the practical applicability of the objectives in the CAPE syllabus. What better way do we have of demonstrating these practical applicability than the use of an SBA? Let us look at some of the main features of the SBA. It should be presented in a report format. It may be done in groups of 5 or less. There is a word count of 1500 words. Keep in mind that 2 marks will be deducted if these words are in excess of 200. Words do not include table of references, table of contents, appendices, and figures. Let us now look at the components of this SBA. The components of the pure mathematics SBA are as follows: the title, the problem statement, the identification of elements of the problem, the solution to the problem, the discussion of findings. And keep in mind that marks would also be allocated to the overall presentation. Each component will be subsequently discussed. The first component we'll be looking at is the title. Keep in mind that the curriculum document emphasizes student-centeredness. So, the SBA must meet the student's needs. That is on page 50. The curriculum document specifically said also that teachers must guide the students to completing this project. That relates to their interests on page 52. With this in mind, coupled with the reality that students are doing other A-level subjects, titles may be suitably found in the A-level subjects that these students are doing. So to find these SBA titles, one may consider if the student is doing business. If the student is doing business, then titles can come from the following objectives in the curriculum. Critical path analysis may be used to determine priority areas in a project. Risk management also may be used to determine the probability of success or failure of a project. Calculus may also be used to determine total revenue. Keep in mind that the first 2 objectives are found in the Applied Unit 1 syllabus, whereas calculus is found in the pure mathematics. The student may also be doing chemistry. Objectives from the syllabus can come from matrices, and these may be used to balance equations or differential equations. The student may also be doing physics. Here one can consider vectors and matrices or rates of change as a possible objective to derive the SBA. Economics. Objectives from economics can be as follows: probability, differential equations, and linear programming. The student may also be doing biology, and objectives can come from probability, differential equations, and logarithms. If a student is doing computer science, then his SBA title may come from the following objectives: logics and Boolean algebra, switch circuits and logic gates. And finally, he may choose to look at complex numbers to derive his title. After looking at the objectives, you can look at these real-world events that can create the issues to form your SBA. Looking at everyday issue, we can zero in on the following: issues at the workplace, issues related to school events or school situations, sporting issues, social issues, money issues, or any other issues that concerns the researcher. Keep in mind that writing the title must meet the following criteria. It must reflect what the project is all about. It should be clear and concise. One should also ask themselves if the issue is solvable. Is it within the scope of the syllabus? Can the research data be obtained? And does this SBA title have the potential of gaining full marks in every single component? These are some of the considerations that must be given in writing your title. Now that we have our title, we are going to use our marking criteria to check for alignment. If the title is clearly and concisely written, 1 mark is allocated to that. If the title relates to a real-world problem, then you get another mark for a total of 2 marks. Let us now look at the problem statement. A problem statement is a concise explanation or description of an issue that your research is attempting to address. The purpose is clearly to identify the issue that is of concern and focus it in a way that allows it to be studied systematically. According to Perelman et al., there are 3 main features of a problem statement. A problem statement should have the problem itself being stated clearly and with enough contextual detail to establish why it is important. It must also contain the problem-solving method. Additionally, it must contain a statement of objective and the scope of the document. Let us examine the first feature of the problem statement, that is, stating the problem. When stating the problem, please ensure that you include the following. State what motivated the study. State why addressing the problem is important. You need to also explicitly state the problem. Stating the ideal situation and the reality is also recommended. These often differ from each other. Together, all these features come together to form the contextual background. The second feature of the problem statement is the method of solving the problem. The problem may have several approaches to solving it. These approaches may be listed and a statement may be made about your chosen solution, justifying it. The third and final feature of the problem statement is the purpose. Here you must clearly state your purpose and objective of the study. That is, you must state what you intended to achieve at the end of the project. Remember, your objectives must be SMART. This is an acronym that means the following. S is for specific. You should ensure that your objective statement is clear and it covers what your project is going to be about. And you must start with an action word. M is for measurable. You must be able to reflect to see whether the project was a success or not. It must be achievable. Here is where you will ask yourself the question, is this project doable? R is for realistic. Can this project be achieved with the resources that you have available to you? And the T is for time bound. Can it be done within the time frame that you have at your disposal? These are the considerations that must be made in writing your objectives. Once you have completed your problem statement, you can juxtapose your problem statement with your marking criteria. If the problem is clearly stated and appropriate in level of difficulty, then 1 mark is allocated for this. If the purpose is clearly stated and relates to a real-world problem, then you are allocated 2 marks for a total of 3 marks. Looking at page 4, section A, the first 3 points there is reflective of Colliers' problem-solving process. Let us see if I'm speaking the truth. The first stage of Colliers' problem-solving process is to understand the problem, and the syllabus stated for mathematical modeling, you should first identify a real-world situation to which the model is applicable. The second stage of Colliers' process is to devise a plan. The syllabus says, as the second point, to carry out the modeling process for a chosen situation to which modeling is applicable. These 2 steps mirror each other. The third stage is to carry out the plan. In the syllabus, they advised you to discuss and evaluate the findings of the mathematical model in a written report. Again, these 2 stages are synonymous. Colliers' process has a 4th stage that was not mentioned, so I am going to advise that you reflect or engage in a metacognitive process. That is, after you would have had your mathematical formulation, look back to see if the process is free from flaws or any inaccuracies. The first stage of Colliers' process is to understand the problem. This is synonymous to identifying all the elements of the problem. In identifying the elements of the problem, you should state what you are trying to find out, what is known about the problem, and here you will include the theories, the formulae, the discoveries, limitations, and exceptions. And you can also state what is not known about the problem, that is, what is undiscovered or unexplored. This is usually a very technical piece, so it may or may not be included in identifying your elements of the problem. You should also state if there were any credible mathematics researchers that may have solved similar problems. That is, you're going to state what the researchers said about the problem. Here are a few more considerations you should have in identifying all the elements of the problem. The second stage in Colliers' process is to devise a plan. To do this, you will need to marry the concept with the mathematical principles. Here you are going to show how the concept of the problem relates to the mathematical model. Let's see an example. Suppose a footballer from the SSFL, that is the Secondary School Football League, wanted to investigate how he can improve his free-kick-taking skills. Here, he may require the following. He may need to know trigonometry, vectors, statistics, and functions. Marrying the concept with the principle would involve showing how trigonometry is related to solving the problem. You may say, for example, bearings and angles of elevation may be used to determine the direction of the kick and the angle above ground the footballer needs to kick in order to achieve the optimal results. The third stage of Colliers process is to execute the plan, that is, to use an appropriate mathematical method or strategy. This involves mathematical modeling of the problem. Here is where you should ensure your mathematical model is accurate, and this is where the teacher's guidance is paramount. The teacher should ensure that the student has the correct mathematical model. Next, you should ensure that all mathematical components are fully explored. That is, correct rules must be used, combined, or correct deductions and relationships must be made. Thirdly, mentions can be made of various strategies employed to solve the problem and why the strategy used was selected. Some of these strategies may include proofs, drawings, or established theorems. After you have formulated your mathematical model, then you juxtapose it against your marking criteria. If you have identified all the elements of the problem and you have shown a complete understanding of the relationship between them, then you would have had 2 marks for this. If you showed understanding of the problem, concept, and mathematical principles, then another 2 marks will be allocated. If you used appropriate terminology and notations to model the problem mathematically, then you would have gotten 2 marks. Also, if you used appropriate mathematical methods for the problem or task, then you would be allocated another 2 marks. This would give us a total of 8 marks. The other component is the problem solution. Here is where most of the mathematics takes place, but not so fast. Before you attempt to solve any problem, any assumptions made must be stated explicitly. Keep in mind what an assumption is. An assumption is a statement that is introduced into an argument whose truth value is temporarily accepted as true. For example, in the free kick experiment, it may be assumed that the wind speed measured immediately before the free kick is taken and the wind speed acting on the ball along its trajectory are equivalent. After stating the assumption, any mathematical proof that is needed must be clearly done. Keep in mind that not every mathematical solution requires a proof. However, when a proof is required, it must be clearly stated. For example, if you are to prove something directly, direct proof must correctly combine axioms, definitions, and established theorems. For combinatorial proof, correct application of the combinatorics must be done. In other words, if something requires permutation, you should not be using combination. Probabilistic proof must clearly state the appropriate probability theory to establish the proof. And if you were to prove something by contradiction, then you should identify the true statement before the logical contradiction. Diagrams are often used in your problem solution. Any diagram drawn as part of the solution must be appropriately labeled. For example, if you have an Agenda diagram or all graphs or statistical chart, then you should ensure that titles, axes, mapping rules, critical regions on graph, and legend, all these must be labeled. Every salient point on the graph that is critical to your solution should be labeled. Also, if you had Venn diagrams or Euler diagrams, which are similar to Venn diagrams, then all the critical relationships must be labeled. If you had a complex object, especially an object that is unfamiliar with the mathematician, then the salient components of these complex objects must be labeled. Continuing with the problem solution, it should be noted that when you are required to calculate, the theorem and the formulae that are used to solve the problem must be appropriate and the calculations must be done free from error. For example, if the exact roots of an equation are needed and the candidate used linear interpolation to approximate the roots, which could have been calculated using factor theorem or any other means, this is an example of an inappropriate use of a theorem. This is because the exact roots were required when the student or researcher used approximate roots. I cannot overemphasize here that the teacher's role is critical, especially to ensure that the correct formulae or theorem was used and the calculations were indeed free from error. Continuing, the solution to the problem must be clearly stated and the results must be suitable for the intended purpose. The solution to the mathematically modeled problem should be clearly written and the contextual meaning of the numbers must be boldly written in at least one sentence. For example, in the free kick model, a 40-degree angle of elevation and a mean velocity of 15 meters per second at a 35 degrees clockwise angle from the line measured between the footballer and the left post, together with the mean wind speed variance of plus or minus 8 meters per second, may be your calculated values. Hence, it would be your duty to transform these numbers into a meaningful sentence. The numbers must mean something. So this will be transformed, or this can be transformed to read as follows. The optimum free kick is made when the footballer kicks the ball at a 40-degree angle of elevation with an average velocity of 15 meters per second at a clockwise angle of 35 degrees from, and you explain further. This is because he scores the greatest number of goals under these conditions despite a plus or minus 8 meters per second variance in wind speed. Here you can relate what the numbers are saying to events within the experiment. And this is basically what they are asking you to do. Now let us look at the component discussion and findings. Marks are awarded if the discussion is coherent, concise, and relates to the purpose of the project. In writing up your discussion, you should ensure that key findings are summarized. You should state your hypothesis, whether it was accurate or inaccurate. You should also compare the results of your study to any similar studies that have been conducted by notable people in the profession. Finally, you should discuss future potential for research. Discussion of findings cannot be done in the absence of recommendations. Here are some of the features of your recommendation. Remember, the acronym SMART stands for specific, measurable, attainable, realistic, and time-bound. Finally, a conclusion must be included in your discussion of findings. The conclusion is succinct, fully reflective of the objectives, and is supported by evidence. The conclusion should be constructed by first restating the problem and summing up the entire paper. You should state your conclusion in clear, simple language. Do not simply reiterate the results of your discussion, and indicate opportunities for future research. If these elements are done, then you will have a perfect conclusion. Now let us juxtapose our discussions of findings with the marking criteria. If the discussion is concise, coherent, and relates to the purpose of the project, then 2 marks are awarded. If the recommendations are relevant and practical, then 2 marks are awarded. If the conclusion is succinct, fully reflects the objective, and is supported by evidence, then 2 marks will be awarded, for a total of 6 marks. Though you have completed the SBA, marks are also awarded for your overall presentation. If you communicated the information in a logical way, using the correct grammar and the appropriate mathematical jargon at all times, then marks are awarded. If appropriate citation of sources are given, this means your in-text citation, then marks are awarded. If you included a bibliography, that is, to reference all the material that you use that are not yours, then marks will be awarded. Let us see how many marks are awarded for each section. If you communicated the information in a logical way using correct grammar and appropriate mathematical jargon at all times, then 2 marks will be awarded to you. If appropriate citing was done, then 1 mark will be awarded for this. And if you included a bibliography, then you will be awarded 2 marks, for a total of 5 marks. This concludes your SBA. This is the end of the video. You can leave a comment in the description below, or you can email me at the email address seen below if you wish to get a free sample of the Pure Mathematics SBA. Please don't forget to like, share, and subscribe.